All right, let's look at this section, angle identities. So this question says, what is the exact value of cosine 15? Well, when it says exact value, that means don't use your calculator, try to calculate it by something. So there's nothing that we know at this time to calculate cosine 15 because cosine 15 degrees is not in the unit circle. So what are we going to do? Well, we are going to use some formula or sum and difference formula. So there are three different formulas, obviously, for sine, cosine, and tangent. And it's pretty easy, but to remember. But before I tell you how to remember, let me just give you the formula. So the sine A plus B formula is sine A cosine B. Okay, and then plus cosine A sine B. Okay, and let's try the difference formula. Difference formula means we're going to subtract two angles. So this is going to be sine A cosine B. And since this is a difference formula with a minus in between, we're going to use minus here. And then cosine A sine B. All right, let's look at the cosine formula. Cosine formula is going to be, so if we're adding two angles together, A plus B, it's going to be cosine A cosine B. And what's a little bit strange about this one is if it's a plus sign, then you're going to put a minus sign here. Okay? And then you continue with the formula. The formula continues with sine A cosine, sine B. All right. So same thing with A minus B. If it's going to be A minus B, you're going to, again, start with cosine A cosine B. And we need the opposite sign of whatever is given. So we're going to put a plus here. And then sine A sine B. Okay, well, that's hard to remember, right? Just a lot of sine and cosine with different orders of A and B. And, sometimes you change the sign, sometimes you don't change the sign. So this is how you remember. There is a chant that goes with this. And I know I cannot make you chant right now because I can't see you, but I want you to chant along because if you do, it will help you remember the order that you're supposed to write a formula. And if you just kind of think like I'll remember, it's gonna be a little tough. So just sit in front of your iPad and just chant along. Okay, so the chant goes sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Okay, so how does that work? So if you look at the formula, we say sine, cosine, cosine, sine, cosine, cosine, sine, meaning the sign has to change, sine, sine. Okay, let's try it again. Sine of the first angle, cosine of the second angle, cosine of the first angle, sine of the second angle. Cosine of the first angle, cosine of the second angle, sine means change the sign, sine of the first angle and sine of the second angle. All right, let's try to chant together and memorize the formula. Okay, so 1, 2, 3, go. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Okay, pretty easy, right? Try to do it one more time to make yourself memorize the formula. 1, 2, 3, go. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Okay, so pretty easy to remember. This is going to help you figure out how to do the sum and difference formula. And it's also going to help you with some of the formula in the next section as well. All right, last one, tangent. Well, tangent, there is no, I don't have a clever chant for this. For the most part, you could just remember that tangent is sine over cosine. So you can just remember it's sine a plus b over cosine a plus b. And then if you can find out the value for each one, you can just divide in, get the answer. However, tangent does have its own formula that has nothing to do with sine and cosine, and you would be able to use it for, in the times where the only thing that you're given is tangent. And I want to make sure that you do have that formula. It's going to be tangent A plus tangent B over 1 minus tangent A tangent B. Okay, so kind of hard to remember. All right, tangent A minus B. So again, you can use sine over cosine, and that should take care of most of the problems. But in the case where the only thing you're given is tangent, then using this tangent formula is much easier. So tangent A minus tangent B over 1 plus tangent A tangent B. So this is kind of hard to remember because you have two signs and they're opposite. The first one goes with the original one. The second one, you have to change the sign. And on the top, you have two things that's added or subtracted. On the bottom, you have a 1 plus or minus, and then you have two tangents multiplied. So a little bit difficult there. All right, well, we spent a lot of time going over formula and memorizing formula, but how do we actually use it, and what does that have to do with cosine 15? Well, if we have to find the exact value of cosine 15 and we cannot use a calculator, then what we're going to do is we're going to use our knowledge of the unit circle, and we're looking for two angles in the unit circle, which if I add them together or I subtract them, using sum, so adding to that together, or subtracting, which is the difference, somehow I can get 15 degrees. Okay, so think about it. Which two angles, when you add them together or when you subtract them, you get 15 degrees. But those two angles have to also be in the unit circle, so then we know the values of them. Okay, so you probably said something like this: cosine 45 minus 30 degrees, right? Ooh, that negative sign is too high. Okay, so this is going to be cosine 15. Okay, so if we can apply the formula for cosine of some angle minus another angle, we can solve this one. All right, so let's remember the formula for cosine. Okay, so let's do a chant again. Sine, cosine, cosine, sine. So this one's going to be cosine, cosine, sine, sine, sine. Okay, so that means cosine, cosine, sine tells me to change my sign. Sine, sine. All right. Now you have to have already memorized your unit circle, or else this is, definitely going to take too long. Okay, cosine 45, square root 2 over 2. Cosine 30. So think about where 30 degrees is, and then the x direction. How long is that x direction? Square root 3 over 2 plus sine 45. All the 45s are square root 2 over 2's. Sine 30, that's going to be the 1/2. Okay, now let's simplify this. So this is a little review of radical functions and what we do with them. Square root 2 times square root 3 is what? Square root 6. Okay, and then denominator 2 times 2, 4. Plus square root 2 over 4. All right, what is square root 2 plus square root 6 plus square root 2? Is that square root 8? No, So if the radicants are not the same, you cannot add them. So it's just square root 6 plus square root 2 over 4. That's it. So this is the exact value of cosine 15. All right. So this is quite long to write all of these formulas. So what happens is that in the book, they put this plus minus. Plus minus, when I tell you guys that whenever you square root something, there's plus minus, it means it's plus or minus. In this case, it's not saying that you can have either one. It's saying that if you're going to use the plus version, you're going to use I'll show you how it is, this particular part of the formula. All right, so let me kind of show you. So sine A plus minus B. So let's kind of remember our chant again. Sine, cosine, cosine, sine. Okay, so the way this works is if you're using the plus part, which is the higher part, okay, the higher part of this formula, then you're going to use the higher part of the actual formula. So that's how it works. Okay, now let's go to cosine. Cosine, cosine, sine, sine, sine. Okay, so same thing with cosine. If you are using the higher part of the formula, you're going to use the higher part of this written formula. Okay, so that's how it works. It's not saying that you put plus minus on every single problem. Okay, tangent, same thing. Tangent A plus minus tangent B over 1 minus plus tangent A tangent B. All right, that was quite long. So let's go ahead and have you practice. So let's do sine 75. This is one of the easier ones. So think about two numbers that add together to get 75 or subtracted to get 75. I think the easiest one you can think of is probably 45 plus 30, right? Okay, now go ahead and apply the sine formula. So sine, cosine, cosine, sine. And then plug in your unit circle values and then figure out the answer. So pause the video, come back and check your answer. All right, so here's the answer, and it is the same as that previous problem. All right, let's give this one a try. Cosine 195. So pause the video, come back and check your answer. All right, so here's the answer. Negative square root 2 minus square root 6 over 4. All right, let's try the last one. Tangent of negative 15. So two angles that add together or subtract together to get negative 15. This one I'm going to do it with you guys because it is long when we have tangents, because we didn't memorize any of the tangents. It does take a lot longer. Again, you can try doing sine over cosine if you want, or you can just use the tangent formula. I'm going to just use the tangent formula since we haven't used it yet, and I want to make sure that you guys are at least exposed to how to use it. So let's try this one with the tangent formula. So tangent negative 15, that's going to be 30 degrees minus 45 degrees. Okay, tangent formula. So tangent formula says we're going to take tangent of 30 degrees minus tangent of 45 degrees over 1 plus tangent 30 degrees, tangent 45 degrees. All right, let's do a sidebar. We need to figure out what tangent 30 and tangent 45 is. So tangent, remember, is sine over cosine. Okay, so make sure you write sine 30 over cosine 30, not sine over cosine, and you have a common 30. That doesn't make any sense. Okay, sine 30 degrees is going to be 1/2. Cosine 30 degrees is square root 3 over 2. So complex fraction, we have top fraction multiplied by reciprocal of the denominator. So we get 1 over square root 3, and we want to rationalize that. We get square root 3 over 3. Okay, so a lot of skills involved, right? In this question, we have like the complex equations or fraction chapter, and we have the radicals chapter as well. Okay, so that's tangent 30. Now let's figure out tangent 45. Tangent 45 is sine 45 over cosine 45. Sine 45 is square root 2 over 2. Cosine 45 is also square root 2 over 2. So this is 1. Okay, let's finish this problem. So square root 3 over 3 minus 1 over 1 plus square root 3 over 3 times 1. All right, we have, again, a complex fraction we had to simplify. Hopefully you remember that if we have more than one fraction inside another fraction, the fastest way to get rid of all the denominators at once is to multiply by the least common denominator. In this case is 3. So we're going to multiply by 3 over 3. And then what's going to happen is you're going to distribute to every term in that section and then cancel the denominator if you can. If it doesn't, then you just multiply. So then in the first top left hand corner, that becomes square root 3 minus 3 over 3 plus root 3. Are we done? No. So if you look at this problem now, we have square root in the denominator. And if you remember in the radicals chapter, that cannot happen. We need to multiply by conjugate. So we need to multiply the conjugate. Conjugate is 3 minus square root 3. All right. In the numerator, we're going to FOIL. Okay. So FOIL. Okay, the first term becomes 3 root 3. And then the second term, root 3 times negative root 3 is negative 3. All right, next one. Negative 3 times 3, that's negative 9. And then the last one, negative 3 times negative root 3 is plus 3 root 3. In the denominator. Now, the reason we want to multiply by conjugate is so that we can see that it is an a plus b times a minus b. So please just do that. A plus b times a minus b is a squared minus b squared. So this is just going to be a squared minus b squared. If you don't do that and you FOIL, it's just going to take way too long. So please take some shortcut. All right, so combine like terms. 3 root 3 has another 3 root 3 there, so that's going to be 6 root 3. Minus 3 minus 9 is minus 12. In the denominator, 9 minus 3. All right, simplify some more. We're almost there. This is over 6. Okay, every single term has a 6 to cancel, so this becomes root 3 minus 2. We're finally done. Okay, so tangent questions are the longest ones because there's just so much work to do. So please do them carefully so you can get them all right. Okay, so I'm sorry I added this in the notes. I forgot to take it out. So we're actually going to skip this part. I think the previous page is enough work to practice for homework. This part we're going to skip because we'll cover it again in pre-calculus in much more detail. So we're just going to end it here for this section.